to go through today is just basically a quick introduction to Python. It's not going to be, super comprehensive, as in, like, I'm assuming that everyone has some base in programming languages, so we're just going to kind of work off of that, and then specifically kind of point out the things that we think are going to be beneficial for our project. So first, general setup. So for the sake of our project, we're going to be developing from the Raspberry Pi, and that's going to be in a Linux environment. So for now, there's no real need for us to set up a Python environment on our personal computers. So for the sake of learning and practicing, there's a couple options. You can either use an online compiler, which is what I'm going to do today. Okay, so first, just general syntax stuff with Python. Some of the things that are going to be most different from languages that you've used before are: one, there's no need to declare variables. Python's dynamically typed, so you can use variables immediately. So you can just say x equals 5, and it's going to figure out that you want it to be an int. You can actually set the same variables. You can change the types of variables. So you could say x equals 5, and then you could say x equals the string we see. So there's no issues there. So that's nice. Another thing is there's going to be no semicolons at the end of lines. We just separate statements by new lines, basically. And then in general, your code is going to be organized with indentation. So basically, instead of having your curly brackets separating big statements and things and blocks of code, everything's going to be dictated by indent. So that's really important to keep in mind. Usually it's 4 spaces per indent or a tab. People have their opinions on that. Okay, operators. General operators, most of them are pretty much the same as you'd expect. The arithmetic operators, your plus, minus, multiply, divide, all those. You're gonna have the same comparison operators. Some things that might be different are your logical operators, is they're going to actually be the words. So you might be used to using, for and, you might be used to using like the double ampersand, or you might be used to using the flagpole things. So that's something to keep in mind. That means that a lot of your statements are going to be look basically like sentences. I have an example up here at the top right. This is a perfectly valid statement. So make sure you just make use of your parentheses, and everything will be okay. Identity operators are used to check if objects are or are not the same object. So I have an example up here in the middle. And so we made x some list, and then we said y equal to that list, which means that if we ask if x is equal to y, or x is y, then that's true because they point to the same object. By contrast, if we separately declare them, or even though they equal the same thing, they are not the same thing, and that's why x is y comes out to be false. So something to keep in mind. And then finally, there are membership operators, so in and not in. So that's basically what's going to tell you if something's in a sequence. So that's like a string, a list, a dictionary, anything like that. So up here, we're saying, okay, we have this list y, and we can say, is 5 in y, and that's going to come out to true. So that's a good way to check or find things in lists and things like that. Okay, and then definitions. These are, your equivalent to functions or methods. The thing to keep in mind about Python is that you don't need to separate, you don't technically need to put everything in functions. You can actually just run your file from the beginning, and it'll just run it from the beginning. So definitions actually function just like variables in that you can only use it chronologically. So you can't, take a definition and define that at the bottom of your file and then use it at the top, like you might be able to in other languages where everything is kind of put in functions. So you have to use them chronologically. You can overwrite them, which is a little weird. What we've done is we've defined this function add that's going to add two variables x and y. So we're basically, again, notice that we haven't, said add int x or int y because we don't, declare the types of variables. So that means you kind of have to know what those are supposed to be. And then if you're using other modules and stuff, the documentation should tell you what the variables should be and what they should represent. So basically we've defined this function and then we've initialized two variables A and B. And then we've called that function. So add A, B. So does anyone know what this is going to return or print? You'd actually be right if we did this. We would actually print 36. But by initializing them like this, we are implying that they're integers, a 9. Yeah, so when we run that, yeah, it's going to print a 9. So they're just going to add. So this, we've sent in a string, so they're going to concatenate the string, and you see it returns yes, no. So the interesting thing about Python is you can actually redefine functions, just like you can redefine variables, right? You could go here and you could say, okay, I want a to equal 7 now. You can redefine functions. So now we have the same function definition as above, but now we're just going to return something else. Another interesting thing is these definitions aren't scoped the same way that functions in other languages are. So you can actually access variables from outside of the function, which can be dangerous. So just keep that in mind. So basically what happened here is we had the same, we sent in the same X and Y, right? The same A and B. And then we added this A from above as well. So this is basically A plus B that it's returning this 12 for. So the thing with this definition then is, okay, we have this print, add, yes, no. Does anyone have a guess as to what's going to happen? Okay, so let's try. And yeah, so it's going to actually throw an error because it doesn't know how to concatenate A, which is an integer in its mind, with a yes and a no. And there are other ways, to concatenate integers and strings. I can show you, we could have done, so there are a lot of ways we could have done this. In this case, it basically points out that just be careful about your variables and know what your functions are doing to avoid errors that you don't want. Okay, one other thing is we can, inside our definitions, we can, so say we did this, right? So we're taking this variable A, and we already know that this function can access variables from outside. What does it do if we change the variable inside? Does anyone have a guess for that? So basically what I wanted to point out was if we change the variable from outside inside, it's going to use that new variable definition inside the definition. However, it's not going to change the variable outside. So you see that even though we said a equals 5 in here, a outside here is still going to equal the original 3 we set it to. Back here. Okay, so we're gonna keep going with definitions. So now we have something called unpacking. So one cool thing about Python definitions is you can return multiple objects, and they return as a tuple. And if anyone doesn't know what that means, that just means they return as, you know, a pair or a triple of items. And then you have the power to unpack them at the other end, which we'll go here and I'll show you. So I'm just using the random module here. That's just to kind of show you, this is how we do import statements, just import whatever you want to import. And so I've made a definition roll dice, and we're picking a random integer from 1 to 6, 2 of them, and then we're going to return both of those. And so I kind of gave it away because it's over here, but roll equals roll dice is going to return basically an ordered pair defined by first and second. And so that's that print. Now unpacking is basically we have two variables, 1 and 2, and we're going to set it to that tuple. So this roll here equals, you know, 5, 6. And so now if we print 1 and we print 2, we'll separate that. And this is going to be different numbers because it's obviously randomized. But so we have 5, and then by unpacking these variables, we have 5 and 1. So that's a thing to keep in mind. And you can do that directly with the functions as well.
Classes. So with a class, you can create a new type of object, like how we were talking about strings and ints earlier. Once you've created your new type, you can create many different instances of that type. So you can have one variable, which is that type, and then you can have a second variable, which is also of the same type. And so you define it with a class and then whatever your class name would be, and then a colon, just the same as for defining functions. And then, so the cool thing about classes is that you can create a function or attribute that's specific to the class. Like how we saw for adding, it works differently for strings and integers. So if you wanted to write a function that's specific to your class, you would use the class name and then dot, and then the function, and then that's how you'd call it. So I don't anticipate that we would be using these too much in our project, although we could. But you'll see it a lot if you try to look into how certain libraries work. So I wanted to make sure that you guys understand it.
Okay, so the next thing is loops and conditionals. This is, you know, a lot of, you know, the main part of how we kind of use our code. So one thing is for loops, and there are so many different ways to do for loops. You guys are probably most comfortable with the format of for loop that goes something like, for integer I equals 0, I is less than, you know, 5, I plus plus, and then you go through your loop by index. That's probably the type of looping that's, you know, most commonly used in a lot of languages. So you can do that type of loop. That's what we called, you know, a range-based loop. So you go for I is going to be your index. In range is a function that returns a list of numbers in a given range. So here I put committees.size, and that's basically going to give you a range in the list 0 to size -1. Another thing you can do is you can say range 0 to 5 or range 5 to 7, and that'll give you a range like that as well. So then, you know, we can just access our list variable using the same notation that you're probably used to with lists. Now, one thing I'll mention is, so I've imported NumPy. So this is the most commonly used module for arrays and lists and things like that. This is the common way of importing NumPy as we go import NumPy as NP. You'll see that in a lot of other people's code. And that's basically, it's a way to not have to write NumPy dot every time. And you can just say NP dot, and that kind of simplifies and shortens your code basically. In the context of this example, a NumPy array isn't strictly necessary, but I put it in here to just kind of make you aware of it. There are a lot of really good array operations that documentation allows. So do go look through that and kind of see what's possible with these kind of lists and stuff like that. In any case, we've initialized an array with 7 items. And so this first thing, we're going to loop by index. So like I said, we're going to go through and then we're going to access variables. Another type of for loop is we can loop by value. So this is also a thing you can do in other languages, is we're just going to actually access the item itself. So this is in situations where you don't actually need the index for any reason and you really just need the object. Then you're just going to say for some variable, and this is the variable, these variables are just, what you define, and these are what you're accessing. These are the list you're accessing. And so we're just going to directly access the value in the list. The next one is using enumerate. This is probably one of the most useful ways to loop through a list. And this is basically you can access the index and the value all at once. So here, this is some funky print formatting so that you can concatenate integers with strings. So if you've done C, then it's very similar to that notation, where you first put your whole string and then you define the variables outside of it. That's what this is. And then finally, something really cool is you can loop over 2 lists at once. So that's using the zip function. And what the zip function is, it just takes 2 lists and it matches pairs, right? So it's going to match this item to this item and this item to this item. And it only loops through to the shortest list. So if the 2 lists are of different sizes, then it's only going to loop up to the shortest list size. So then you can access pairs of values at once. So that's helpful. Other things are you have your if statements. So this is pretty much just how you would expect. Just remember, no curly brackets, just colons. There's no else if, it's just shortened to elif. And then you have your while loops. I didn't bother putting an example here, but that's the same, just while colon. One thing to keep in mind here is you'll notice is that you don't need parentheses here. That's stylistically up to you. I think in a lot of cases when you have like compound things like we had before where we were doing this, this kind of thing, parentheses are going to help you organize your code. So don't be afraid of them. And then other things are just break and continue keywords. If you're familiar with those from other languages, they're going to function the same way.
Like modules, libraries, and APIs, which, like it says here, are arguably one of the most powerful things about Python. There are a lot of modules that can help you do pretty much whatever you want. I know I'm reading off the slide, but it's perfectly written. I can't think of something where there's not a module, unless it's like something that you can do in one line in Python. So you've seen a couple modules and libraries being used in the examples that we've shown so far. There's NumPy, which we saw. There's pandas, which is used a lot for data stuff, and then requests, which lets you get to the internet. And then there's also some built-in modules that you don't need to install or anything like that. Things like JSON, which will let you access things in a JSON format, which is a specific way that some kind of data is organized. There's time date, which will deal with all your time and date stuff. CSV, which lets you access CSV files like spreadsheets. And then base64, which is some basic encoding stuff.
Yeah, and one thing about the built-in modules is they are built in, which means you don't have to install them, but you will have to still put in that import statement at the beginning. A quick point on documentation is that a lot of the Python modules, the ones that aren't built in, they're coming from a lot of different places. So the documentation is going to be different for every module you're using. It's going to be formatted differently. And in my experience, some documentation is better than others. I've and then it's also always great for me to go and find an example of someone using the code and using the module to really kind of understand myself how to best use different functions and things like that.
There's so many resources that you can build on top of for Python. You really don't need to start from scratch. And then so some best practices just to make everyone's code looking nice and consistent are, of course, I'm sure they tell you this in all your classes, comment a lot, make sure it's obvious what your code is doing. And then if we name variables and functions consistently with the underscore, it'll be easy to understand what's going on in the code. And then if we use classes with like, I don't know what this
Camel case, I think it is called.
I think camel case is when the first one is lowercase.
Maybe.
Yeah. But as long as we have a consistent style for naming things and everyone keeps up with it, that would be amazing. And then so the style that we're going to be using is PEP 8. And you can check out this website if you're concerned or you have some doubts, but I wouldn't be overly worried about all the style stuff because we can implement what's called a linter that will basically check your code as you submit it or as you write it, and it will highlight the parts that are wrong, so you can go in and fix it at that point.
So use your best judgment and mostly just stay consistent and make sure your code is readable.
Yeah, the readability is the big thing. Like that's what the point of the style guide is. Okay, so now we're getting to the exercise. If you remember from the beginning, we gave you some online IDEs you can use. Like